got credit for the radio. And regardless that he stole 17 of Tesla's patents, put his radio together, Tesla actually had his patent for the radio in 3 years before even Marconi did, but for some reason, it kept getting onto the bottom of the pile. And it wasn't until after his death where the patent office said, oh, you know, Tesla actually invented radio. He invented remote control wireless systems. He was just amazing what he could do. And all his thoughts were in his head. He didn't have to write anything down. He could visualize an invention and then put it together in his head before he even touched anything. One of the funny things is, like, Edison was Mr. Trial and Error. And they asked Tesla one day about it, and he's like, yeah, well, he goes, if Edison was looking for a needle in a haystack, he would take one straw at a time and remove one straw at a time until he found that needle. And that's how he did his inventions. Where Tesla, on the other side, used science. He goes, if I was looking for a needle in a haystack, I'd run a magnet through it and find that needle a lot quicker. Anyway, that's AC versus DC. And if we have time, I will show you that video. It's a great video. Okay, we talked about women being more susceptible to shock. So, true or false? Electrical accidents are the third leading cause of industrial deaths in the U.S.
True.
And true is correct. Shocks involving DC tend to push the recipient away, while shocks involving AC tend to grab hold of the recipient. True or false? Nobody? False.
False.
DC tends to grab you, or AC blows you away. Lower levels of AC than DC can lead to fibrillation of the heart muscle. True or false?
True.
False. Women are more sensitive to the effects of both AC and DC than men. True or false?
True.
True. Okay, common electrical problems. So this, as you can see, this kind of PowerPoint is going to give you little test questions that you can go through as you review it again. Again, we talked about power strips. They're only used for computers or electronic equipment. They are not made for plugging in a whole bunch of appliances just because you don't have enough outlets on your counter. And also, this power strip here, as you notice, is just a power strip. It is not a surge protector. It does not protect anything. And if you have anything that's electronic, whether it's your TV, your stereo, your computer, you should have a surge protector on it. Especially like if there's a power outage, because you can get a spike come back when they turn back the power on, and it could smoke your TV or your computer if you don't have a surge protector there. Extension cords are for temporary use only. And if you have to have an extension cord more than temporary use, you need to actually get rid of the cord and get some hard wiring in there, because it's a trip hazard. It's a danger hazard. As you can see here, they got some tape on this cord. So this cord has already been damaged just by probably doors opening and closing. And that's a big issue right there, having those exposed wires. So if you have a cord that has exposed wires like that, it needs to be replaced. or you cut off the end and put on a new end and make it shorter.
When you said trip hazard, do you mean literally like a person tripping over the wire, or do you mean trip like it'll
Yep,
trip the
exactly.
breaker? Oh, okay.
No, like you're gonna fall on your butt because you got your feet tangled up in an extension cord.
Got it. Okay.
And that's why a lot of for like when they do concerts and things like that, and we have to run temporary cords to power things. There actually have, you'll see like a rubber
Those covers.
channel that goes over it that gives you a step to walk over where you won't trip on the cord itself. Okay, so difference between a short circuit and an overload circuit. A short circuit is where the hot and the neutral, or the hot and the ground, are in direct contact, and there is zero impedance. There's no resistance at all. And you get an inrush of current. A standard circuit breaker, for example, has an inrush current of 10,000 amps. But the circuit breaker will drop as soon as it notices that there's a short. Overloaded circuit means that you just have too much load on that circuit. For example, I did that monster house, and I replaced 2 of the circuit breakers in this guy's panel because they were no good. And then he called back complaining that his circuits were tripping. And it's like, okay, so then I had to go there, and it's like, well, what do you got here? He goes, well, I got my toaster oven going, I got my microwave going, then I got my coffee maker, and I do the blender, and I'm trying to make my smoothie, and boom, everything blows. And I said, you're way overloading the circuit. And I start giving him the amperage rating of each of the appliances, and I go, you only got a 20 amp circuit, and you're running over 35 amps through it. And he's like, well, it never broke before. And I said, that's because you had defaulted circuit breakers and you were risking a fire. And he's like, oh, okay. So an overload is when you just have too much load on that one circuit. Where a short, there is no resistance at all. It's just hot to ground. So here's an example of an overload circuit. You got a power cord, they got all kinds of different things plugged in, all trying to run off this one little cord. And that's just another way to cause a fire, because if it doesn't have a built-in circuit breaker, this cord can overheat with all the other things that are plugged into it. Power cords, you got to make sure that they're not going to get damaged either from heat. For example, this here is a hot surface that could melt the cord, or you could have a doorway that could cut the cord, or anything like that. So you want to make sure that when you're dealing with an appliance, you're not exposing it to some type of physical damage. And there's just another example of improper wiring. So, power strips are approved for use with computers and computerized equipment only. True or false?
False.
True.
True. Extension cords are approved for temporary use as well as permanent installations. True or false?
True.
False.
True. Come on, Carlos. We just said extension cords are for temporary use only, not permanent installations.
I misread it.
A short circuit causes an increase in resistance and a decrease in current. True or false?
False.
False. It's the exact opposite. There's no resistance, and there's a massive amount of current. So, bonding and grounding. When dispensing flammable liquids from a container larger than 5 gallons, the container must be bonded and grounded to prevent buildup of static electricity. Now, one of these things, even if it says 5 gallons or greater, that's quite not the story. You can have a 2-gallon container. If you go online and look up, what would it be? Gas station fires. And what you got is you got a guy, he dries up in his pickup. He's got a plastic container inside the bed of his truck, which has a plastic lining. And so what is plastic? An insulator. What can hold static electricity? Insulators. So he doesn't take the gas can out of his truck. He just pulls the hose over, opens up the gas can, starts to fill it up, and then there's a spark from static electricity, and the whole thing blows up in his face. You see that with people with jet skis. You know, they're towing their jet ski down the freeway on that little trailer, and they got their little plastic gas can. Well, anytime you got wind coming over something, that's going to build up a static charge. And that static charge has to be discharged before you open it or fill it up with gas. So if you're ever filling up a gas can, even if it's in your truck, take it out of the truck and set it on the ground to ground it. Now, if you live out in Palmdale or the like, you know that the wind blows a lot, and you probably have a lot of static issues. One of the tricks that I've learned over the years is, let's say you're in the market and you're trying to shop and you reach for a can, it's like, damn, got hit, right? Just take one of your keys, hold the key, and then touch it to something metal. And if there's any static charge built up on your body, it's going to discharge at the end of the key. You're not going to feel a thing. And you discharge yourself, so now you're not going to get shocked by static. Good buddy of mine lived in Palmdale for a while. And he goes, you got to see this. This is unbelievable. And it was a windy day, and he's got like this thick plush carpeting. And he's in his socks, and he just kind of shuffles in his socks into his walk-in closet. And he grabs a fluorescent light bulb, and the light bulb glows. Because of the static charge in his body was exciting the phosphors in the fluorescent bulb and made it glow. Pretty weird. So you always want to look out, especially when you're working with gasoline or anything like that, that you have some type of discharge of any type of static electricity. That's why they do it with planes. If you notice, when they fuel a plane, first thing they do is they set up a grounding system and they ground the plane to get rid of any static discharge, because the fuel that goes into a plane is like 120 octane compared to your 80 octane you get for a regular car. So here's an example with the plastic bed liner, and you put in the plastic gas can in there. It's going to build up a static charge. You need to set that on the ground. You try to fill it up in the truck, you could end up with an explosion. Like I said, they got plenty of videos online of these people getting blown up. Okay. Water and electricity, any receptacle within 6 feet of water should be GFCI protected. We talked about GFCI protection. Kitchens, countertops, garages, outdoors. And the GFCI protects you from an electrical shock, but it does not protect you if you're touching the neutral on the GFI, because then you're just a light bulb to the GFI. And this is a picture of an eye wash that's right next to an outlet without GFCI protection. So that's not good, especially if someone puts their face in there to wash it and it can splash into the outlet and cause an issue. Power supplies. Power supplies can boost your power immensely. For example, like a power supply for a neon sign is like 15,000 volts to light up that neon sign. So you got to be careful about what you're doing and what you're using. Capacitors. This is a good one. Capacitors are a way to store electrical charge, and if you actually touch the two ends of a charged capacitor, you get one heck of a shock because it would discharge on you. So when you're working with a capacitor, we had a capacitor tester where I used to, when I was at physical plant, and we had a button where we'd push the button and it would short out the two leads and discharge the capacitor, so then you could test it. So if anyone tosses you anything that looks like this, step away, let it drop, because if you grab it, they're like, got you, shocked you. Someone tried to do that with me, but I didn't trust them for a mile, so I was just like, whoa, I ain't catching that. And that's a typical. What's that?
How do you discharge the capacitor?
Well, there's two ways. You can either, if you have a capacitor tester, it has a button. When you plug it in and you hook up the two leads and you just push the button and it'll short it out. Or you can just take a screwdriver and go for, like, here on this capacitor, you got this terminal and this terminal. If I just went with a screwdriver across those two terminals, it's just going to go pop, and it's going to discharge all the energy from the capacitor. Capacitors are used a lot in lighting for
all the different HID lamps.
Yeah, the HID, high intensity. I was trying to think of the word. Yeah, the high intensity discharge lamps require a capacitor, because the capacitor, what it does, its job is to build up this electrical current and voltage and then go boom, and it gives it like a shock to start something. So capacitors are used a lot just to start up a motor, start up a light, things like that. Transformers. You need to know what you're dealing with, what the transformer is, because it could be a high voltage or it could be a low voltage. You know, we have step up and we have step down transformers. And we even have transformers that go from 120 volts to 120 volts. And why would you do that? It's called an isolation transformer. And so what it does is, let's say I have 120 volts coming in from a building, and I've got this testing room. And everything in that testing room has to be perfectly clear, clean voltage. I can't have any spikes or anything. So I would take it through a 120 volt transformer to 120 volts, and then it would clean the power source. So there was no way I could get a spike or an inrush current from outside of that testing room, because I have what we call an isolation transformer. So a transformer can step up the voltage or it can step down the voltage. It doesn't change it from AC to DC. Don't confuse a transformer with a rectifier. A rectifier changes AC and DC. So for example, you may have a new truck or car and you got a 120 volt outlet in the car to plug in your laptop or something. Well, that's going through a rectifier, changing the DC power from your car to AC so you can plug in your laptop. Transformers either increase the voltage, decrease the voltage, or keep it the same. Whether it's a step up, step down, or just an isolation transformer. So explosions can occur when gas cans are placed on the bed liner before they are filled. True or false?
True.
And true. Power supplies represent a potential lethal source of electrical energy. True or false?
True.
True.
True. Once disconnected, capacitors become de-energized. True or false?
False.
False. They can still shock you. Okay, section 3. So here we have a GFCI. We have different wiring conventions, but don't take anything for granted. I was at one house where the entire house was wired with green wire. The hots, the neutrals, the switch legs, everything was green. And that is not legal, for one. And there are some wire conventions that are required by the code. For example, a white wire is a neutral wire. That is called your grounded wire. The green or bare is your grounding, and then black, red, or blue are your hots. But I've seen people use yellow, orange, red, purple, brown as a hot wire. Is that good practice? No.
Were they at least labeled, the green wires?
Nope. It was one mess.
That's
It was
crazy.
terrible.
What's the difference between the neutral and the ground wire? I know.
Okay, good question. The neutral wire is the wire that is intentionally grounded as a return path from the hot and the neutral. The grounding wire is also intentionally grounded, but it is for safety. So if something metallic and it's grounded, then if there's a fault, it'll trip the breaker. So the ground wire is, or the grounding wire, I should say, is either green or bare, and it is not supposed to be carrying electrical current. The neutral wire does carry the current because it completes the path for electricity to flow between the hot and the neutral. And if you take 117, you'll learn more about that. Luis, go ahead.
I was just saying yes, sir. Makes a little sense, but yeah, I should take the class.
Okay. So this is, I showed you guys that the receptacle PowerPoint, right?
Yeah.
Well, this is
Yes.
like the receptacle tester here. And what it does is you just plug it into the outlet and it tells you if it's open, if you have an open neutral, open hot, or if you have your polarity reversed or anything like that, or if the wiring is correct. It'll tell you with just plugging it in once. Great tool to have. Okay, with circuit testers, big thing on that is know the voltage you're working with. We had years ago at Valley College, there was a temporary electrician working at the college, and there was no electrical supervisor. His supervisor was a carpenter, and they had a power outage. And the power that goes between the buildings and the colleges is 4160, 4,160 volts to every transformer room. And then from there, it's transformed down to a usable voltage, 110, 220, 277, 480, and so on. Well, they had this power outage, and in walks the temporary electrician into the vault. In walks the carpenter, who does not belong there. He's not a qualified person. In walks a custodian, and then a small engine mechanic comes in. And they're all like, hey, what's going on? And the carpenter goes, can you test to see if there's power? And the guy's like, yeah, sure. And he opens up this 4-foot, I'm literally, it's 4 feet high disconnect. That's got to be your first clue that it's big time, right? And he takes a simple solenoid tester, which is like right here, and it's only rated for 600 volts. And he goes to test 4160 with it.
Jeez.
The thing exploded like a grenade. Blew this guy 10 feet back in a fireball into a block wall. And the only person with any sense was a small engine mechanic. He was like, maybe I shouldn't be here. And he starts to walk out the door. And what happens is that electrical arc flash was so bright that it burned the retinas in his eyes. And he's walking around and he sees stars in his peripheral vision from the arc flash. So whenever you're working with a meter, first know the voltage you're working with. Then you determine whether the circuit is energized or de-energized. And you don't take anybody's word. Don't go, gee, Carlos, did you shut off the breaker? Yeah, you're good to go, Dave. No problem. Next thing I know, Carlos is at my funeral going, geez, man, I got the wrong breaker.
I set him up, man. I set him up.
You don't trust anybody, and you don't trust your meter. So you take this is the actual thing you should do, is you take your meter, test it on a known live circuit. Yep, meter's working. There's no break in the leads or anything, right? Then you go test the circuit that you want to be de-energized, and you find that it's dead. Then you go back to the energized circuit and test your meter again to make sure you didn't blow any fuse or something, and it's still working. Then you know that it is safe to work on that de-energized circuit.
That's where lockout tagout comes in, right?
Well, lockout tagout's another part of it. That way, with lockout tagout, you can't be going, oh yeah, I got everything off, and then Johnny come lately comes around and goes, oh look, circuit breaker's off. Let me reset that. And shocks the heck out of you. So lockout tagout stops people from being able to re-energize a circuit. For example, at Trade Tech, once a year we would service all the transformer rooms. Okay, and remember the transformers are what? 4160. So we would crank down the breaker. It was actually like you know how you have that crank to start an old car? It's similar to that. It was what we call racking down this breaker. We'd rack down this huge breaker. It'd drop out and go clunk. And then we would take a hot stick, we would make sure that the transformer was off, We would count the number of tools we walked in with. We would count the number of tools we walked out with. Everybody who was involved in that situation had their own padlock on a lockout tagout device. And then we all had to be back at the circuit breaker to remove our locks. So we didn't like leave someone behind. Oh, Felipe is still there. Go ahead and turn it on. And he smoked Felipe, so he's done. So everybody had to be present to remove their lock. And again, like I said, we would count the tools when we went into the room, and we would count the tools when we went out. So you didn't inadvertently leave a tool in the transformer room. One of our retired HVAC instructors was also a HVAC tech in physical plant, and he actually left the rag in a compressor that he rebuilt for an AC unit. And when he turned it on, the rag got stuck and blew up the whole unit. So you just got to make sure that you are always using safe practices. And lockout, tagout is a big thing, and you learn that in your OSHA class. You need to get your OSHA 30 card in second semester. This is talking about surge suppressors. And surge suppressors protect your electronic equipment from electrical spikes. Because you can get a surge of 200 volts on something that's only 120 volts, and it's going to smoke it. The best thing with a surge protector is when you buy one, make sure the surge protector has a light on it that says, yeah, I'm still working. Because it's just like a boxer. It can only take so many punches before it's done. And then once it's knocked out, it's no longer a surge protector, it's just a power strip. And you're not protecting anything. I'll give you an example with the bookstore. We had a power outage over the weekend. And you'll learn more when you take DC theory. You'll learn about Lenz's law. But what happened was we had this huge inductive motor that was 60 horsepower that was running the cooling tower. Well, when the power went out, the induced voltage from that motor spiked back, and it smoked the $5,000 main brain for all the registers in the bookstore. So the bookstore was out of business. And I got called in that morning, and it was like, oh yeah, I'm looking at it. Yeah, you could just smell the smoke coming out of the computer. And I go, yeah, you got a surge on your computer. And I said, you didn't have a surge suppressor. And the bookstore manager's like, well, what's a surge suppressor? And well, it protects electronic equipment from spikes and high voltages. He goes, where do I get one of those? And I said, well, come with me. And we walked out of the bookstore, and I pulled one off the shelf for him. He sold them at his own bookstore, and he didn't know what they were. And it would have saved a $5,000 computer if he had a surge protector. And it's all about you get what you pay for. One of the best surge protectors out there is called the Trip Light. They're super high end, and especially like if you got high-end stereo and audio equipment, you want a Trip Light surge protector. But the typical $30 one at Home Depot would work fine. What you want to look for on a surge protector is, one, it has a built-in circuit breaker, so it'll trip if there's too much voltage or current going through. And also it has a light that tells you that it's still working. Because if it doesn't have that light, you don't know if the surge protector is still a surge protector or if it's just a power strip. Because once it goes bad, it's no longer protecting it. It's just a power strip. We've talked about GFIs. Lockout, tag out. Here's an example. See this one here? There's 6 holes there. So up to 6 guys can put their own lock on that. So nobody could turn on this disconnect until all 6 guys remove their lock, or however many guys are working on it. And everybody has their own key, everybody has their own colored lock, and nobody else can take off the lock but the person who put it on. Common signage. All right, the neutral wire or white wire is not a shock hazard. Shock hazard. Say that.
False.
False. My worst shock I ever had was from a 277 volt neutral. I probably told you that story. It was
Forearm,
terrible.
right?
All those lights were wah, wah. That hurt. Always check a known live circuit with your meter before testing for voltage on another circuit. True or false?
True.
False.
True. You always want to make sure the meter's working, because it could have a blown fuse or it could have a nicked lead or something. A GFCI shuts off the flow of electricity upon sensing a fault condition. True or false?
True.
True.
What happened? My slide's not working. Answer is true. Okay, number 1. I mean, this is with anything, not even electricity, just with anything. Do not attempt any work you feel uncomfortable performing. If you're not comfortable with a table saw or a, what do they call those? A planer or anything like that, don't mess with it. Get somebody who knows how to use it. Don't use it yourself. Same thing with electricity. If it's out of your wheelhouse, walk away. Say, no, that ain't me. It's like, oh, the power line's down. That ain't me. You know, let's call Sam. She can come out and take care of that high voltage stuff. I'm out. Wear proper insulated boots and gloves is necessary. Pretty much personal protective equipment. You should always have safety glasses on. Most places require reflective vests now. Hard hats. You see, hard hats required in this area. Then you want to have safety boots. For example, we do not allow anybody at Trade Tech to wear open-toed sandals. It's like, sorry, you're not at the beach. You're here, and if you drop something on your foot, it's gonna hurt.
But Professor, it's insulated.
What, your open-toed sandals?
I'm just kidding. It's a rubber one.
They're not insulated to when you drop the hammer on it. But if you got, good sturdy leather boots, it's not gonna hurt as much as if you did it on your sandals. Go ahead and get some bare feet, Luis, and go ahead and drop a rock on your foot. See how that feels. And then put a pair of boots on.
Are Crocs okay?
What's that?
Steel-toed Crocs.
Yeah. Well, Crocs, okay. That is a safety shoe. Okay, see what you got there? Those Crocs that Carlos is showing? Who wears those? Besides Carlos. Chefs.
Number 1.
If you go to like a culinary institute, you'll see everybody clomping around in some kind of Crocs, and usually they're like super yellow or super pink, like Carlos is,
Slip resistant.
or anything like that. What it is if they spill a hot liquid, it's not going to puddle in their shoe and burn them more. They can just kick off the Crocs and get the liquid off of their feet as quick as possible. So that's actually a safety shoe for culinary people. Lockout, tag out, you'll learn all those procedures when you take the OSHA class. If you're working with higher voltage, always keep one hand behind your back or in your pocket so that if you do get shocked, it's not going to go from one hand to the other and go across your heart. It's going to go down to your foot or something like that. And you're not going to be putting that electrical current across your heart. But generally, it's like 99% of the time, you should be able to work everything that's dead. You don't work something hot. Sometimes you have to work something hot, for example, if you're troubleshooting and you're trying to find out, is there voltage here? Is there not voltage here? Is there voltage here? Well, you have to have power to check that. So with troubleshooting, you will be working with live voltage, but other than that, if you're doing an install, there's no reason for you to go, oh, I'm just gonna swap out this switch. And I'm not gonna bother going down the panel and shut off the power. I'll just swap out the switch, I'll be careful. And the funniest thing, we had this big old cornbread white boy. He was like 6'5", and he was like from Iowa or something. And he's in 4th semester. And you're supposed to follow lockout, tag out, and everything. And then he's swapping out a switch hot. And the guy next to him goes, dude, you didn't lock it out. You need to shut off the power. He goes, oh, I do this all the time at my grandmother's house. And it blows up in his face. And it's just like, and I happened to be walking by, and I just shook my head and you knucklehead. There's no reason to work anything hot if you don't have to. With capacitors, make sure you fully discharge them, and the easiest way is just short circuit them with a circuit or a screwdriver. Emergency numbers, yeah. Okay, so if someone's hooked up and they're being shocked, don't grab them and try to knock them off. Use something that's non-conductive or push them away, or better yet, go and just shut off the current. So the most common symptom of electrical shock is physical shock. They include cold, clammy skin, pale face, chilled feeling, or patient is physically shaking. Like I told you, when I got hit by that 277, my hand was shaking like this for 5 minutes, and I was like, I'm gonna kill somebody. Whoever was in that. It can cause nausea and vomiting and shallow breathing. So what do? You keep them lying down, make sure their airway is open, elevate their legs, make sure there are no broken bones, keep them warm if conditions are cool or damp, give them fluids if they're able to swallow, stay away from the beer, don't give them alcohol, and then just reassure them that they're going to be okay. We got you. Help is on the way. Okay, we already went over through the fire extinguishers. So quick review. To ensure safety during repairs, lockout, tagout procedures should be employed. True or false?
True.
True. Type B, CO2 fire extinguisher should be used on electrical fires.
False.
True or false?
False.
False. It's type C.
Where you be?
Electrical shock can cause nausea or vomiting. True or false?
True.
True. Electrical accidents are the 3rd leading cause of industrial deaths in the U.S. True or false?
True.
True.
Shocks involving DC tend to push the recipient away. while shocks involving AC tend to grab hold. True or false?
False.
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 It's the other way around. Lower levels of AC than DC can lead to fibrillation of the heart muscle. True or false?
False.
False.
False. DC has the lower levels. Women are more sensitive to the effects of both AC and DC than men. True or false?
True.
True.
True. Power strips are approved for use only with computers and computerized equipment.
True. False.
False.
True.
I thought you could use it for more.
Power strips are only for electrical equipment or electronic equipment. Extension cords are approved for temporary as well as permanent installations.
False.
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 False. A short circuit causes an increase in resistance and a decrease in current.
False.
False.
False. It's the other way around. Explosions can occur when gas cans are placed on a bed liner before they are filled.
True.
True or
True.
false? Power supplies represent a potential lethal source of electrical energy. True or false?
True.
True.
True. Once disconnected, capacitors become de-energized. True or false?
False.
False.
False. The neutral wire or white wire is not a shock hazard. True or false?
False.
False.
False. Always check a known live circuit with your meter before testing for voltage on another circuit.
True.
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 True. A GFCI shuts off the flow of electricity upon sensing a fault condition.
True.
Answer was true. For some reason it bailed out. All right. So that is another PowerPoint you can use when you're going through the